Hello, this video is on Gibbs free energy, or the total amount of energy available for a reaction to do work. It's basically how much energy you can get out of a reaction. Now, it also tells us whether something's spontaneous or not. So, if it's a negative delta G, then it's spontaneous. If it's positive, it's non-spontaneous. It goes back to the whole idea that nature wants to get to the lowest possible energy state. And the lowest possible energy state would be if something gave up energy, or negative delta G. The equation for this is delta G equals delta H minus T delta S. So it introduces the whole idea of temperature as well. So we're going to start with this reaction that we've been doing for the last couple of videos, and that's the combustion of hexane. And we're going to see whether it is spontaneous or not. Well, we kind of know it's spontaneous. It burns. So that's a big hint that it's going to have a negative delta G. But remember, we have a negative delta H, which is favored, and a negative delta S, which is not favored. So there might be a temperature at which this isn't spontaneous at all. So this is sort of what we need to do. We're going to say that delta G equals a negative 8326.4 kilojoules. Now that was from, that's basically the enthalpy, that's delta H of our reaction. That's this guy right here. Okay, and then we're going to say, well, let's say this is at standard temperature, which is 25 degrees or 298.1615 Kelvin. So that's what we're going to do. So minus temperature, which is 298.15 times a negative 106.52. Now we have to be careful here. The delta S of this problem, or this reaction, is 106.52 joules per mole K, not kilojoules. So what we're going to do is change it to kilojoules. The easiest way for me to do that is to say times 10 to the negative third. So that will change it into kilojoules for us. We're increasing the size of the unit, therefore our number has to decrease, and therefore the negative. So I'll go ahead and do that. I'm going to put K on the bottom. I'm going to put K here, and you can see why we have K's, so they cancel out. Now once we do this, delta G, now notice what happens. This is a negative and a negative, therefore it makes this whole thing right here positive. Makes this whole thing positive. So we are going to expect this negative 8326 to increase a little bit, become less negative. So in actuality it does go to 8294.6 kilojoules. Still negative, and therefore spontaneous. This chart shows us what happens when different combination of delta H and delta S. So we have a negative, and a positive will always, delta G will always be negative, and it will always be that at all temperatures. If you have a negative delta H and negative delta S, which we do in this case, then it's negative at certain temperatures. So the reaction is spontaneous at certain temperatures, usually at low temperatures. So maybe at high temperatures this one is not. If they're both positive, then the reaction is spontaneous at certain temperatures, like high temperatures. If delta H is positive, which is not favored, and delta S is negative, which is not favored, then delta G will always be positive and will never be spontaneous, will never react spontaneously. So a common problem that's posed to us is this. is there a temperature at which this is non-spontaneous? Since our reaction is spontaneous now, let's see the temperature at which it becomes non-spontaneous. Well, what we can do is the following. We can set delta G to 0, because delta G is 0, it's sort of that balancing point where it could be spontaneous or not spontaneous. So if we set delta G to 0, it looks something like this. 0 equals negative 8326.4 kilojoules. That's delta H. Minus, and then there's that T times negative 106.52 kilojoules per K. Okay, so if we solve for T, T basically looks like this, becomes like this. T equals delta H over delta S. So in this case, T equals negative 8326.4 divided by negative 106.52. Now if you do this algebraically, you'll see that both negatives sort of either cancel each other out or don't exist. It depends how you go ahead and solve it. These are both kilojoules, and this is kilojoules per K, so that's going to cancel out. These guys cancel out, and you have the units K, and this ends up being a big number, 77869 kilojoules. Now, the meaning of this is the following. At this temperature, really high temperature, this reaction stops. It won't go any further. Okay, so it becomes non-spontaneous. Those are typical problems. Good luck, and hope that helped.